Regularization in machine learning. AI intermediate level. Introduction. Machine learning models learn patterns from data during training. However, sometimes a model learns too much from the training data, including noise and random fluctuations. When this happens, the model performs well on training data but poorly on new unseen data. This problem is called overfitting. To prevent overfitting and improve generalization, machine learning uses a technique called regularization. Regularization helps models learn simpler and more general patterns instead of memorizing the training data. It is widely used in regression models, neural networks, deep learning systems, recommendation systems, natural language processing. Understanding regularization is essential for building robust and reliable machine learning models. What is regularization? Regularization is a technique used to reduce overfitting by discouraging overly complex models. In simple terms, regularization equals a method that prevents models from learning unnecessary complexity. Example concept. Training data means model learns patterns means regularization controls complexity. Regularization improves the model's ability to generalize to new data. Why regularization is important. Machine learning models with too many parameters may memorize the training data instead of learning meaningful patterns. Example concept. Complex model means memorizes data means poor generalization. Regularization encourages the model to learn simpler patterns. Example concept. Regularized model means simpler patterns means better predictions. This improves performance on test and real-world data. Overfitting versus underfitting. Regularization is closely related to the concepts of overfitting and underfitting. Overfitting. The model learns the training data too well. Example concept. Training accuracy high means test accuracy low. Underfitting. The model is too simple to capture patterns. Example concept. Training accuracy low means test accuracy low. Balanced model. The goal is to achieve good generalization. Example concept. Good training accuracy plus good test accuracy. Regularization helps achieve this balance. Mathematical idea of regularization. Regularization adds a penalty term to the loss function. Example representation. Loss underscore new equals loss underscore original plus lambda CDOT regularization term, where L O S S O R I G I N A L loss original equals original loss function. Lambda equals regularization strength. Regularization term equals penalty for complex models. The penalty discourages very large weights. Types of regularization. Several types of regularization techniques are used in machine learning. The most common include L1 regularization, L2 regularization, dropout, early stopping. Each technique helps prevent overfitting in different ways. L1 regularization. Lasso. L1 regularization adds the absolute value of weights as a penalty. Loss equals loss underscore original plus lambda sum W underscore I. Effects of L1 regularization. Reduces model complexity. Forces some weights to become zero. Performs automatic feature selection. Example concept. Unimportant features means weight becomes zero. L2 regularization. Ridge. L2 regularization adds the squared value of weights as a penalty. Loss equals loss underscore original plus lambda sum W underscore I squared. Effects of L2 regularization. Prevents large weights. Improves model stability. Reduces overfitting. Example concept. Large weights means penalized means smoother model. L2 regularization is commonly used in neural networks. Dropout regularization. Dropout is widely used in deep learning models. During training, dropout randomly disables some neurons. Example concept. Neural network means randomly drop neurons means prevent overfitting. This forces the network to learn redundant and robust features. Typical dropout rates: 0.2, 0.5. Dropout is commonly used in CNNs and deep neural networks. Early stopping. Early stopping prevents overfitting by stopping training when performance stops improving. Example concept. Training error decreases. Validation error increases. Down pointing arrow. Stop training early. This prevents the model from learning noise in the training data. Regularization workflow. Regularization is applied during model training. Typical workflow. Dataset. Down pointing arrow. Train model. Down pointing arrow. Add regularization. Down pointing arrow. Reduce model complexity. Down pointing arrow. Improve generalization. Regularization helps models perform better on unseen data. Real-world applications. Regularization is widely used in many AI systems. Computer vision. Preventing overfitting in deep CNN models. Natural language processing. Regularizing language models. Finance. Improving stability in predictive models. Healthcare. Preventing overfitting in medical diagnosis systems. Recommendation systems. Improving prediction accuracy for user preferences. Advantages of regularization. Regularization provides several benefits. Advantages include: reduces overfitting, improves generalization, stabilizes model training, prevents extremely large weights. Example concept. Regularization means simpler model means better predictions. Limitations of regularization. Regularization also has some limitations. Challenges include: choosing the correct regularization strength. Excessive regularization may cause underfitting. Tuning parameters can be time-consuming. Example concept. Too much regularization means model too simple. Careful parameter tuning is important. Concepts learned from regularization. Understanding regularization helps learners understand. Checkmark how machine learning models avoid overfitting. Checkmark how model complexity affects performance. Checkmark how neural networks become more robust. Checkmark how training stability improves. Checkmark how real-world AI systems achieve better generalization. Regularization is a key technique for building reliable machine learning models. Simple definition. Regularization. A technique used in machine learning to reduce overfitting by penalizing overly complex models. Final summary. Regularization is an important technique used to improve the generalization ability of machine learning models. By adding penalties to the loss function or limiting model complexity, regularization prevents models from memorizing training data. Techniques such as L1 regularization, L2 regularization, dropout, and early stopping help control model complexity and improve performance on unseen data. Understanding regularization is essential for building robust machine learning and deep learning systems.